All right, so remember back to kind of the beginning of the thing, we went over the Pauli exclusion principle, and we said that no two electrons can have the same four quantum numbers. And as we're seeing, these kind of orbitals and these electron configurations are all based on these quantum numbers. So again, Pauli exclusion principle, you don't have to know the name, just have to know the principle, I guess. Is that no two electrons have the same four quantum numbers. At least for the electrons within one atom. If they're in different atoms, then I guess they can have the same quantum number. But no two electrons in the same atom can have the same four quantum numbers. So let's just take a look at a hypothetical atom here. We have 1s. We're going to fill that up with 2 electrons. 2s, we're going to fill that up with 2 electrons. And then 2p, we'll fill that up with 2 electrons. Keep an eye on how I'm filling these, and you can think about what this atom is. So let's just go over the quantum numbers and see how they're different. So let's first take a look at an example where we have both electrons in the same orbital. So in this case, we're going to take a look at the electron on the left and then the electron on the right. So the electron on the left, n is equal to 1. Same thing for the right, right? This is the n, so n equals 1. They're both in the s orbital, so L is equal to 0 for both of them. So that makes sense. And m sub L, when L is equal to 0, m sub L has to be 0. So 0's there. So you can see so far we've got the same 3 quantum numbers. Can't have all the same 4, so the 4th one must be different. And that's obvious in this example right here because I've drawn the electrons, right? One of them is spin up, one of them is spin down. So this one, m sub s, is equal to plus 1/2, and here m sub s is equal to negative 1/2. So you see they don't have the same 4 quantum numbers. In terms of kind of comparing maybe this electron and this electron, you can see here that the n is different, right? So if they're different n's, they're not going to have the same 4 quantum numbers because the n is going to be different, right? So that's pretty obvious. And then let's take a look at kind of these 2 electrons over here. So this one and this one, how are they different? Well, let's take a look at their configurations, right? They're both in the n equals 2, right? They're both in the 2p orbital. And p, remember when we have p, our L is equal to 1. And they're both spin up, so they're both m sub s equals plus 1/2. So think about what's different. What's different is going to be the m sub L. Is this visible? I don't like that. Need more colors. Go with the galaxy one. M sub L. Remember here we have L equaling 1. So m sub L can equal -1, 0, and 1. And this is what tells us how many orbitals we have in different orientations. So we can just arbitrarily label them -1, 0, and 1. They're all degenerate, so it really has kind of no meaning. You can't say the one on the left is definitely -1. It doesn't really have that much meaning. And so one of the electrons, maybe this one, has an m sub L of -1, and then this one right here has an m sub L of 0, right? So you can see no 2 electrons will have the same 4 quantum numbers. So this is a question that gets asked. I can give you an orbital diagram, and I can ask you what are the 4 quantum numbers for this electron.